For a 150 amp service upgrade, the size of the bonding wire for the junction box is determined by the size of the service conductors feeding the panel. According to the National Electrical Code, specifically Table 250.102, C1, which addresses grounded conductors, bonding jumpers, and supply-side bonding jumpers. This table dictates the minimum size of the bonding jumper based on the size of the grounded conductors or the equivalent area for parallel conductors. In this scenario, with a 150 amp service, we need to refer to the appropriate column in Table 250.102. C1 that corresponds to the size of the service conductors. Presuming copper conductors are used, a 150 amp service typically requires at least number 1 American wire gauge copper conductors. Consult in Table 250.102. C1. For copper conductors, the minimum size of the bonding jumper for conductors up to number 2 American wire gauge is number 8 American wire gauge. Therefore, a number 8 American wire gauge copper wire is required to bond the 10-inch by 10-inch junction box. The function of the bonding wire is to create a low impedance path for fault current back to the source, which facilitates the operation of overcurrent protection devices such as circuit breakers or fuses. When a fault occurs, such as a short circuit from a hot wire to a metal enclosure of the junction box, the bonding wire provides a path for the fault current to flow back to the electrical panel. This high current flow causes the circuit breaker to trip or the fuse to blow, quickly disconnecting the circuit and preventing electrical shock or fire hazards. Proper bonding is crucial for electrical safety. Without an adequately sized bonding wire, the fault current may not be high enough to trip the breaker quickly, leading to a prolonged fault condition and potential hazards. Furthermore, inadequate bonding can result in voltage on metal parts, creating a shock hazard for anyone who comes into contact with them. It's also important to ensure that the bonding wire is properly connected to both the junction box and the grounding system. The connection points must be clean and free of corrosion to ensure a good electrical connection. Antioxidant compounds can be used to prevent corrosion at these connection points, especially when dissimilar metals are involved. When splicing the old circuits in the junction box, it's also important to maintain proper grounding continuity. Each circuit should have its own grounding conductor that is connected to the grounding busbar in the junction box. These grounding conductors provide a path for fault current from each individual circuit back to the main grounding system. For the 5 15 amp circuits, 120 amp circuit, and 150 amp circuit, each should have appropriately sized grounding conductors. Typically, for 15 amp and 20 amp circuits using number 14 American wire gauge or number 12 American wire gauge wire respectively, a number 14 American wire gauge grounding conductor is sufficient. For the 50 amp circuit, the grounding conductor size will depend on the size of the conductors used for that circuit. If the 50 amp circuit uses number 6 American wire gauge copper conductors, then a number 10 American wire gauge grounding conductor would be required. All of these grounding conductors should be securely connected to the grounding busbar in the junction box. Additionally, consider the grounding electrode conductor. The grounding electrode conductor connects the grounding busbar in the main electrical panel to the grounding electrode system, which typically consists of ground rods, ground plates, or metal water pipes buried in the earth. The size of the grounding electrode conductor is determined by Table 250.66 in the National Electrical Code, based on the size of the service entrance conductors. For a 150 amp service using number 1 American wire gauge copper service entrance conductors, a number 6 American wire gauge copper grounding electrode conductor is typically required if connecting to a ground rod or ground plate. If connecting to a metal water pipe, the grounding electrode conductor must be at least number 6 American wire gauge, and in some cases, it may need to be larger depending on the size of the service entrance conductors. It is crucial to ensure that all grounding and bonding connections are made properly and are tightened securely. Loose connections can create high resistance paths, which can impede the flow of fault current and compromise the effectiveness of the grounding system. Periodic inspection and maintenance of the grounding system are also recommended to ensure that all connections remain tight and free of corrosion. Furthermore, it's important to note that local electrical codes may have additional requirements or variations on the National Electrical Code. Always consult with the local authority having jurisdiction to ensure compliance with all applicable codes and regulations. Proper grounding and bonding are essential for electrical safety, and it's important to take the time to do it right. This includes ensuring that all grounding and bonding connections are properly sized, installed, and maintained. Firstly, determine the size of the service entrance conductors feeding the electrical panel. Secondly, consult Table 250.102 C1 in the National Electrical Code to determine the minimum size of the bonding jumper for the junction box. Thirdly, ensure that all grounding conductors for the individual circuits are properly sized and connected to the grounding busbar in the junction box. Fourthly, connect the bonding jumper from the junction box to the grounding system, ensuring a secure and corrosion-free connection. Fifthly, inspect and maintain the grounding system periodically to ensure that all connections remain tight and free of corrosion. By following these steps and adhering to the National Electrical Code and local electrical codes, a safe and properly grounded electrical system can be ensured. Remember that electrical work can be dangerous, and it's always recommended to consult with a qualified electrician if there are any doubts or concerns. Improper electrical work can result in electrical shock, fire hazards, and property damage. Always prioritize safety and follow all applicable codes and regulations. When dealing with a 150 amp service, it is also important to consider the working clearances around the electrical panel. The National Electrical Code specifies minimum working clearances to provide adequate space for electricians to safely work on the equipment. These clearances include minimum distances from the front of the panel to any obstructions, as well as minimum widths and heights for the working space. Ensure that the electrical panel is installed in a location that meets these working clearance requirements. Another important consideration is the proper labeling of circuits. Each circuit breaker in the panel should be clearly labeled to indicate what it controls. This makes it easier to identify and disconnect circuits when performing maintenance or troubleshooting. Use a permanent marker or label maker to create clear and accurate labels for each circuit breaker. Also, consider using arc fault circuit interrupters, or size, for branch circuits that serve areas such as bedrooms, living rooms, and dining rooms. Size are designed to detect arc faults, which are a common cause of electrical fires. They can help to prevent fires by quickly disconnecting the circuit when an arc fault is detected. Ground fault circuit interrupters, or GFCIs, are also important for protecting circuits that serve wet locations such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to detect ground faults, which can cause electrical shock. They can help to prevent electrical shock by quickly disconnecting the circuit when a ground fault is detected. Ensure that all required circuits are protected by size and GFCIs as required by the National Electrical Code and local electrical codes. When working with electrical wiring, it is important to use the correct type and size of wire for each circuit. The National Electrical Code specifies the types of wire that are permitted for different applications, as well as the ampacity or current carrying capacity of different wire sizes. Use the appropriate type and size of wire for each circuit to ensure that it can safely carry the intended load. Also, be sure to properly terminate all wiring connections. Use wire connectors that are listed for the type and size of wire being used, and ensure that all connections are tightened securely. Loose connections can create high-resistance paths which can cause overheating and potentially lead to a fire. Furthermore, when running new wiring, be sure to follow proper wiring methods. This includes properly securing the wiring to the building structure, protecting the wiring from physical damage, and maintaining proper spacing between conductors. Refer to the National Electrical Code for detailed requirements on wiring methods. Remember that electrical work can be complex and dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with all applicable codes and regulations. Finally, after completing the 150 amp heavy up, it's important to have the work inspected by a qualified electrical inspector. The electrical inspector will verify that the work has been performed in accordance with the National Electrical Code and local electrical codes, and that the electrical system is safe and properly installed. Do not energize the new electrical panel until it has been inspected and approved by the electrical inspector. By following these guidelines and working with qualified professionals, a safe and reliable 150 amp electrical service upgrade can be ensured. Always prioritize safety and adhere to all the applicable codes and regulations when performing electrical work. Also, ensure the panel is adequately rated for future expansion. Consider the number of available spaces for future circuit additions. It is wise to select a panel with more spaces than immediately needed.